Hello, in this video I'm going to help you to answer a question in AP Physics past paper about a thermal physics questions, question 42 and 43. We have a graph of temperature versus time, and we see the temperature decreases as a curve, not a straight line, from 60 degrees to about 20 degrees. The first question, 42, is very simple. The lowest, the closest temperature to the room temperature, we can see at the end of the graph where the temperature begin to be constant and doesn't decrease anymore, closer to 20. So the answer to this question is 20 degrees centigrade. The next question, 43, is a little bit more difficult. We know that this 8 times 5, 10 to 5 joules of energy is lost by the tank in per centigrade. So we see on this graph, for example, from 60 degree to here about 48 degree in half hour, it decreased more than 10 degrees. So the rate of the cooling decreases with time, meaning when the temperature is high, the rate of energy loss to the surrounding is faster than when it is cold and closer to the room temperature, when the difference in temperature between the water and the room temperature is smaller. So per centigrade, on average, the temperature, the energy loss is 8 times 10 to 5 joules. The question is how many joule per hour? The question is per hour. So we need to determine how long it takes for the water to decrease from the initial temperature, which is 60 degree to 34 degree. And we see from the graph 34 degree is here. So the time is about 1.5 hours. Not exactly 1.5, because this graph is not very clear and with small division so that we can determine exactly the time, but approximately 1.5 hours. And the decrease in temperature from 60 degrees to 34 degrees is 26 degrees. So multiplying this temperature decrease, yes, by the amount of energy, 8 times 10 to 5 joule per degree C. We will get the amount of energy, and then we divide the time 1.5 hours, and we get it's about 1.38 times 10 to 7, which means it is closer to this answer C, and it is not exactly 118 times 10 to 6 joule per hour. Our question is per hour, not just the energy in 1.5 hours. Because the question is approximately, not exactly, because the graph doesn't show us the exact time, 1.5 hour less. It could be 1.4 hours, a little bit less, so that the closest value to our calculation is answer C. So this is how we answer this kind of question. Thank you.